Hello again, welcome back. This is TestDive, our annual conference aimed at tester, and we are ready for our next speaker. Our next speaker is Michał Sajdak, and he will be talking about authentication and authorization. Michał Sajdak is the founder of sekurak.pl and an IT security consultant at Securitum PL. He has over 10 years experience in issues related to technical IT security. He performs security tests and conducts trainings. His certificates include CISSP, CEH, CTT+. He likes to gain access to unsecured cameras all over the world, live during international talks and conferences. So if you ask me, it is both impressive and scary what Michał can do. Michał is also a veteran here at TestDive. It is his third time here with us. We desperately tried to keep him away, but well, we couldn't. So I think the only thing to do today is to put our virtual hands together and have a nice round of applause for Michał Sajdak. Michał, over to you.
Thank you for the introduction. All right, so today we'll be talking about authentication and authorization. And I work in Securitum. I blog at Sekurak, and I'm here on Twitter. And just a quick reminder, what is authentication, authorization, a bit simplified definition. So authentication, confirming that a user is really the one who he or she claims to be. And so authentication most of the time looks like this. So user presents a login. So my login is admin. And the system now asks, okay, are you really admin? Maybe you're lying. So the user should present now, for example, a password. So the admin password is something, something, something. And the system responds, okay, you're really the admin, go on with further communication, stuff like this. So this first part is identification, my login is admin, and the further part is authentication. And authorization, basically speaking, is just checking permissions. All right, and during the presentation, I will cover something like 20 different real-life problems with authentication and authorization stuff. And the short agenda looks like this: a couple of warm-up cases, then a couple of cases about password reset mechanisms, and then something about network devices. And I have also the fourth topic, a little case, how it was possible to hack into every Tesla vehicle in the world. If we have time, we should have time, I will cover briefly also this one. Okay, and one reminder before we start. All the bugs, all the vulnerabilities should be already fixed. And please don't hack systems, even your production systems, without a formal permission. Okay, so the first case is how to get access to many 6.4 million of Israeli voters. This bug was found in 2020, this year. And the first step was just to visit the website, this website, electorco.il, pretty straightforward stuff. Then view HTML source. And as you can see in the HTML source, it was something like this, server URL and get admin users. Then, of course, we navigate to this get admin users, and without any authentication, someone had access to all the stuff, passwords, logins, stuff like this of admin users. And the last step, just log in into admin panel and getting access to all those people. So it's pretty easy, pretty scary, pretty sensitive data, and this happens in 2020. Okay, in our case, Panera Bread. Panera Bread is a restaurant chain in the United States, stuff like bakery, cafe. And some time ago, someone found another very simple vulnerability. So he was able to get many details of any user just by providing simple ID number using this API call. And in the response, it was this, some interesting data. Another API request, he got access to some parts of credit card data, so even more interesting. And this guy sent the information to this Panera Bread, and they fixed the bugs by requiring to be logged in. But hey, everyone can create a free account. So the second approach was to create a free account and then go back here, and it worked. So their final approach was to limit the data you can access to only your own data, not to everyone else. Okay, another case, so child smartwatch, Chinese production as far as I remember. And actually this API, the API which was used to communicate this watch with the internet, with the server, was completely unsecure. So actually no authentication, no authorization, and using simple requests like querying by ID numbers, it was possible to get location access to data, phone numbers, pictures, conversation for more than 5,000 children. It's again pretty scary. And an example response looked like this. So just, API something, 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 ID 12345, and we get this data, for example, location data. And the researcher queried, as far as I remember, all the smartwatches, queried them about the location. And as you can see, most of the watches were surprisingly maybe in Poland. Was it fixed? Probably yes, but you never know how it goes with Chinese companies. Okay, now a bit fun with HTTP headers. So now there's a real bug report from this year, as far as I remember. And normally, the researcher wanted to have access to the admin panel, but he was forbidden, so return code 403. And now goes a little trick. You can use this X original URL header, or alternatively X rewrite URL header. And now what the application thinks. Okay, he wants to get to the main page, all right? So maybe we should give him the access. Okay, there is green, so it's 200 code, okay. But now the application internally redirects the person, the attacker probably, to this admin login URL, and we have access. So just a little trick with those headers. There's another interesting header and another real vulnerability from 2019 probably. And first approach was to access administrator API endpoint. And as you can see, first approach looked like this. So you're not allowed to log in from this remote access. But when someone changed or added this header, so X forwarded for and localhost, so 127.0.0.1, now he got admin access because the application, this API thinks, okay, we have a request, an HTTP request coming from the local host, yeah. So maybe this user should be allowed to access admin, so let's give him access. So a little hint for you, during your tests, you can try to just blindly, automatically add this header and see what happens. Okay, another case from this year, so hacking Starbucks and accessing nearly 100 million customer records. It's pretty big. And the vulnerability is pretty, let's say, straightforward. So you create an account in their system, and you of course have access to your own account. So API request, API version 1, users, me, and something. This gives us information about me. But what happens if you start with the same URL in this second request, but when you add this backslash dot backslash stuff like this? So now API thinks, okay, this request starts with users, me, something. So okay, this is API call for his own data. Okay, you can go. But now we are going back to another endpoint, and now we are searching for all the accounts. So for example, we are searching for accounts which are started, I mean, the username with something, with the letter A, letter B, something like this. And he got, for example, this information. Probably he was able to also search by ID, so search by ID 1, 2, 3, 4, 5, every 100 million users. And you may wonder why this backslash dot here, not backslash dot backslash dot, but this stuff. And this stuff, this single backslash dot was used to bypass WAF, so Web Application Firewall. Little trick, and it allowed to bypass this Web Application Firewall Starbuck says or was using. All right, let's move to password reset stuff. And this is, let's say, normal procedure for resetting password. So you provide your email when you want to reset your password. You receive this email, and finally, you click this email and reset your password. But what happens if, as an attacker, you provide different host header here? For example, your host. Then sometimes, when the application is vulnerable, sometimes the email is sent, of course, all the time. But sometimes the link you are receiving, so I mean this link, reset your password, looks now like this. So it points to completely external domain, which was put here. And now when someone clicks this link, you as an attacker has this reset token, and you can just take over the account. And there is also another scenario for this, and it works in this inventory application. You can try to inject something in this host header, so not only plain host here, but something injected. And here you can see we have sort of simple image tag injected here. And when you are using an email client, which automatically fetches images or previews of images like Gmail, then you don't need to, as a victim, you don't need to click this reset password, but Gmail fetches this link automatically. It sends this request to my server, and the application appends here this reset token code, let's say, or this reset token. So automatically we have reset token, and we can just use it to reset password for this specific user. All right, another quite big case from just a couple of weeks ago. So Grindr is sort of, let's say, sensitive application, and they had really scary vulnerability, because if someone tried to reset password there, so you provided, or the attacker provided an email, this password reset email was sent to the person with the reset token, but reset token was also presented in the response to the attacker, so it's pretty scary. So once again, reset token was sent in the email to the normal user, and simultaneously, it was presented to the attacker in the response. So now he was able to just copy this token, paste this into reset password screen, and set new password, take over the account. All the data, all the account activity was taken. Pretty scary, right? It was just a couple of weeks ago. Okay, another interesting stuff in password reset stuff. So normally, of course, you provide only one email when resetting password. But what happens if you provide a couple of different emails, for example, in a scenario like this, in this JSON? Sometimes it gives you an error, but sometimes there are 2 or 3 emails sent to each of the provided addresses. So again, you have this reset token, and you can change the password. Okay, nice case from Facebook. So actually, some time ago, someone found that he was able to reset password for literally every single Facebook account in the world. He got $15,000 for this as a bug bounty. And this is, let's say, normal situation. So you can reset your password on Facebook by entering phone number, email address, or on this URL. And then Facebook will send you, or was sending you, this 6-digit check code to your phone or your email address. And the natural procedure for an attacker then is to brute force this code. So when he tried this on normal Facebook.com website, such brute forcing of this 6-digit code was blocked after 10 or 12 invalid attempts. Looks good for now. But he tried the same, let's say, procedure. So inserting this code, this 6-digit code, this is 5 digits maybe, here on another website, this beta Facebook.com, so their test server. And the test server is connected to the production database, so you can test test a new feature of Facebook's here using your normal account. But on this test server, on this beta Facebook server, they forgot or they disabled for some reason checking if someone is providing batch code for too many times. So actually there was no rate limit on providing batch codes on this beta server, and this server is or was connected to the production DB, so it was possible to reset password for every user, and the only thing you needed to know was his email and phone. All right. And let's go to completely another stuff. So authentication, let's say, problems in web panels of big network devices. And let's start with this Pulse Secure SSL VPN. What is this Pulse Secure SSL VPN? It's quite common corporate solution for big companies. Big solution for organizing VPN connections. Or just VPN, And there was a vulnerability in this Pulse Secure SSL VPN. It was demonstrated, by the way, on Twitter. So Twitter is still actually using this Pulse Secure SSL VPN as their corporate VPN solution. And the trick was that here is the IP address for the device. Then some magic stuff, this yellow stuff here, and this allowed, without any authentication, to read any files from the file system from this device. So this nice file, as you can see, caches text passwords, so not encrypted or hashed, so text password, plain text, of user who who have just logged in. Someone is logging in. You can just after a while grab this file, and you can see his password in plain text. There's another file for seeing logins of the users. So pretty for attack, you have login password, and you can just log in into the VPN. But you may say, okay, but normally we have two-factor authentication. And we have two-factor authentication. So how about this? And okay, and the researcher showed two different approaches for bypassing this two-factor authentication. And one idea was to get to another file. This random val is not a random val, it's just directory name and data MDB. And he grabbed from there session ID. So if you log in into VPN or probably banking account, for example, you provide a login password, then probably your 2FA code, and then there's a session ID created. So he grabbed just this session ID, and he was able to take over this VPN login session. Okay, so pretty interesting stuff, I think. Another interesting vulnerability in another device, FortiGate SSL VPN this time. And once again, without any authentication, we're able to read any file from this device. And what was the core of this problem? The core of this problem was this line in the source code of this device, of this web administration panel. So normally when we enter login screen, we probably want to have this login screen in Polish. Then we provide this lang equal to PL. Maybe we want this in English, so we can provide this lang as EN. And now what the application makes with this value? So the application tries to read this file. So we have PL here as lang, and this make admin lang PL JSON is read. But we can provide this lang as //////////// and we go to, let's say, root directory, and we can read actually any JSON file. And how we can escalate it to read any file actually, not only JSON. This is the solution for this, because this little thing protects this buffer against buffer overflow. So actually everything which is larger than 0x40 in hex in length, I mean this value, because lang can be provided with any length. So for example, I don't know, 100 slashes. So this final string is cut into maximum 0x40 bytes in hex. So actually we can do something like this. We can provide this lang as slash // now many slashes, not too many, and the file to be read, for example, this one. And what application does? It cuts out this JSON which is outside of this range. So basically we can read any file, and in this file we have login of a user and his password, of course, in plain text. No hashing, no encryption, stuff like this. So the exploit is, as you can see, pretty straightforward. No authentication, and now we have login, we have password. Okay, let's go to something different now. This is common stuff when you are working with Java, or more specifically, if you're working with Tomcat. And the Tomcat is in the backend, and on the front end you have Apache HTTP server or Nginx HTTP server. And what happens then? You can provide to the application an URL looking like this. So we have portal here, semicolon something like manager HTML then. And for Apache, this // semicolon looks like a normal directory. So for example, if you enter, I don't know, Sekurak, and if you put here, I will zoom it for a moment. If you put something like this, so .lot semicolon slash, then the web server says not found. It looks for a directory, semicolon, no directory name like this, so not found. Okay, but for Tomcat, this slash dot semicolon slash is parent directory, surprisingly. So if it goes to the backend, so to the Tomcat, then Tomcat thinks, okay, this is parent directory, so let's remove this portal part and let's serve this manager HTML page. Okay, so a real use of this bug. So this is a real bug from a bug bounty program from Uber, and Uber had this Jira status page available for everyone, so no authentication needed. This is normal, but someone bypassed this stuff by providing this. And Nginx says, okay, we should give access to everything which starts with status. Okay, this starts with status. This is another directory, and something like this. Okay, let's allow this request. Then this goes to the Tomcat running in backend, and Tomcat thinks, oh gosh, this is parent directory. So now this is removed, and Tomcat serves secure dashboard JSPA. So it serves quite, let's say, confidential data. As you can see, there is this dot semicolon stuff in here. So nice method for bypassing, let's say, authentication. And again, this bug was found in quite popular big device, so F5 BIGIP appliance used by many enterprises, by banks, stuff like this. And as you can see, after revealing information about this bug, some organization in the US alerted all the user to patch this immediately because exploitation will be coming in just hours. And here is our new friend again, this dot semicolon. And the exploit, the attack looked like this. So here you have public IP address of this F5 device. Here is the administration panel. Of course, you should have all authenticated access to the login screen. Most of the companies, of course, hide all this login screen and allow this login from all the, I don't know, internal networks. But other companies just present login screen from the internet. But you still need login and password, maybe, two-factor authentication code, stuff like this. But again, this F5 device thinks, okay, this starts with tmui login.jsp. So let's just serve this request without necessity to provide it to give login and password. So no authentication needed, of course, to access login screen. And now this stuff. This is forwarded to the backend. In the backend runs Tomcat. And Tomcat says, okay, this is parent directory. So let's remove this stuff. And let's serve this JSP file. Of course, without authentication, because authentication is checked on the front-end server. And we were able to read every file from this device. And the real attack was, or the real exploit, used another file, another JSP file. And this another JSP file allows to execute any commands on file system, on operating system on this device. So pretty simple stuff, which can be used directly from the browser. Okay, another pretty new stuff. So hacking Facebook MDM. It was, let's say, published, or this detailed write-up was published in September this year. And what happened here, or what is MDM? MDM is mobile devices management. So for example, in the Facebook, they have, I don't know, thousands probably of smartphones, tablets, stuff like this. And if you want to globally, so in one place, restrict or set specific security settings on every single device, you want to get every single device and manually configure it. You can do this directly from MDM. So, for example, whitelist applications which can be used. Turn off Bluetooth, turn off ability to connect to unsecured Wi-Fi networks, disable routing of the device, stuff like this. So if you hack into such system, probably you will have access to every single mobile devices from the company. All right. There are a couple of different vulnerabilities. I will show you all this stuff in a, let's say, short way. And once again, we have this architecture. So Apache listening on the front-end server, and we have reverse proxy running on this Apache currently, and in the backend you have a Tomcat server. And now, all such requests, so to MIFS/services, so to the API, all such requests were blocked or are blocked. Yeah, but we can use another trick. This time we have just one dot, semicolon, not two dots, and we can use this to bypass this filter because only this is blocked. So MIFS services, I don't know, get users, MIFS services, list users, or something like this. But we have now here MIFS dot semicolon services. No, this is not MIFS services. This is MIFS dot semicolon services. Okay, so Apache gives access to the user. You might think, what would happen if we have here only single dot? Then the front server, so I mean here the Apache or Nginx, would normalize this dot into just single slash. So normalization, this will be normalized into MIFS services, and then this check will happen. I know you're blocked. But this can't be normalized because Apache thinks this is directory. Pretty normal directory, so just forward this to Tomcat. All right. And now the final exploit was to find a suitable API function, for example, such a function which allows to create a file with the contents provided by an attacker, and we can create this file with a backdoor, and we can execute any commands on the server. And hopefully this little presentation, it's not made by me, but by the researcher, will be going smoothly. Yeah, and here you will see a real attack against this vulp.fb.com. And this is, let's say, preliminary check if it's vulnerable. So basically speaking, he wants to run a CRL against his domain, so this rceboo.exp.tv, and he monitors his DNS server. And he see that Facebook sent some information to his DNS server, so the CRL run. And now the final exploit. So basically he creates this file on the server, on this vsp.fb.com, and this file should be already created. And now he'll be communicating with this file. Okay, so he adds a refer here. It's a protection that no, let's say, random hacker can enter this backdoor. Okay, and now he is running an ID command on their server. So, okay, ID run. Let's try uname -a. Okay, it ran. So we have, direct shell access to their server, and we can try to infect all the mobile devices. Of course, it would be illegal. So the guy send this information as a bug bounty issue. All right, so let's move to our last topic. And our last topic is a case from a couple of years ago, but in this year it was quite nicely, let's say, described. So how it was possible to remotely hack any Tesla vehicle. So first step was automatic VPN connection from a car to the Tesla network. It happened normally, so no, let's say, security issue here. But the researcher connected, a normal PC or just Linux connected to this car, to this Tesla network, and he started to scan different servers, different IPs. So in other words, he tried to find what can be reachable, what can be reached from this car on this Tesla network. And after some time, he found a server and a file on this server, which was called good-dev-test-carkeys.tar. Interesting, right? And what was here? Here were different VPN keys for development connection. So he was able to use those keys to establish development connection to the Tesla network. And actually, after connecting through this development VPN, he was able to access another server, and on this server, he had access to such temporary 24-hour security key for literally any vehicle, any Tesla vehicle in the world. And after this step, he was able to get root access on any car. Pretty scary, right? What else? He was able to use also those development keys to access Tesla's main server, so this mothership server. And surprisingly, all the commands were accepted here without further authentication. So maybe they have development network, and development, you don't want to bother with providing different credentials for different users, fetching 24 this temporary key. Everything should work because we are testing, and this is our focus. So this allowed us to, or him actually, to access this mothership server, and he was able to locate, unlock, starting any vehicle actually in the world using this stuff. If you want to see more detailed description of all the stuff, here's the link, so you can just take a screenshot for this link. I'll provide also this presentation just in a moment. Okay, so I think we have a couple of minutes more for questions, but before questions, we can sum up what went wrong with this Tesla stuff. So the first problem was weak network separation. So he was able to access many different servers from this, let's say, car network. Wrong. Then unauthenticated access to VPN keys, also some credentials, not nice. And this, I think, the biggest problem, that dev credentials, dev VPN keys could have been used to get full access actually to both cars and to this motherboard, to this main server. Okay, so if you want to get a direct link to this presentation, just please email me. I hope you enjoyed the presentation. If you have any questions, you can just ask me on Discord. I think I'll be on Discord in, I don't know, 3 or 4 minutes. Or you can just ask them now, and the host will just ask me directly about this.
Okay, lovely. Thank you very much indeed, Michał. That was a great talk. And let me start with a question, sort of general, maybe slightly off topic, but I was, very curious to see people, big companies, paying a lot of money to people who found vulnerabilities in their systems. So I remember one of our test Dive talks where someone, one of the speakers, got actually paid $5,000, and today you quoted this case of Facebook who paid $15,000 to somebody who found something. My question is, can you do this for a living? I mean, just do that, just find vulnerabilities and pocket thousands upon thousands of dollars. Do you know anybody who does that?
Just to be clear, you're asking if you can be a bug bouncer and make money only from this?
Yes, exactly. Yeah, just that and nothing else.
Yes and no, because if you're lucky, that of course you can earn some good money. For example, this Tesla stuff, for this Tesla stuff, they paid $50,000, not 15 but 50, so it's quite a good money. But you must be, I don't know, maybe really lucky, or you should maybe put just a huge amount of time for finding different stuff, and in the end you can be with nothing, because you burned 2 weeks of your time and you found nothing. You burned 2 months and you found something for, I don't know, $1,000, and you can, on the other hand, you can allocate 2 or 3 days, and I know people who do stuff like this, and after just 2 or 3 days they earn, I don't know, $3,000, $4,000, $5,000. So it depends on your skills, of course, and also unfortunately on your luck.
Right. So the answer, I guess, is yes, but it's at your own risk, right?
Yeah, exactly.
Okay, fantastic. Thank you very much. And we've got a question from the audience. And the question is there a way that companies can post and read other companies' entries about vulnerabilities and then that they came across, and that would be for a common benefit?
It's a bit tricky, because, for example, maybe let me show you a link. If you enter Hackerone.com, it's a website, this Hackerone.com, which aggregates many different, let's say, bug bounty programs. And there's a link, as far as I remember, activity. A typo here. Yeah, so as you can see, many different vulnerabilities are published here. And here, the companies who are or who were actually affected can agree, or they can say no, we don't want to publish, and this Hackerone just complies with this. And on the other hand, there are researchers who actually don't care about permission, but they send information to the owner, wait for the fix, and they publish the information, of course, without any sensitive leaked data, stuff like this. And it's sort of, let's say, shady area, because some people will say, no, you should keep all the information strictly confidential, and other people will say, oh, you should publish all the information because this is in, let's say, public benefit, and I'm in this second group, actually.
I see. Okay, thank you very much. And there's just one more question from the audience. It's, I guess, personal / professional. What was the biggest bug you have ever found in your career? And of course, it's, in your opinion.
Okay, it's hard to say, because I've had a couple of different interesting bugs in IoT devices. And I think that the biggest bug was, I'm thinking now loudly not to reveal too many informations.
No, you don't want that,
no. But it had huge impact, so it allowed to compromise all IoT devices of a specific, manufacturer in the world with very simple, stuff, even if they were firewalled. This I can say.
Wow.
So, yeah.
Yeah, that does sound big. So did you save the world?
Probably yes.
Okay. Well, thank you on behalf of the whole civilization. Then we've got so many things to deal with these days, so one less. Okay, and one more again, specific about Twitter. Did you investigate a recent Twitter hack that occurred for several public figures?
Not yet. I saw a report or preliminary report about this, but I saw, I don't know, the title of this report, not the contents, and I don't know any details about this. Rumors say that that an account or a couple of different internal accounts were breached. And by stuff like, I don't know, SIM swap attacks, or just by speaking, hey, can you give me the access, my dear friend, I will pay you. And this account was used just to take over all the important accounts. But nothing, okay, I think, confirmed now.
Right. Okay. Thanks for that answer.